In this video, we demonstrate basic router configuration, demonstrate implementation of the DHCP protocol, part of the TCP/IP suite. This protocol is used to assign IP addresses and IP configuration to host machines that are set for the DHCP protocol. Another intent of this network was to introduce the concept of static routing. We'll put that in at the end. An overview of the DHCP operation. DHCP servers listen on layer 4 port 67. DHCP clients listen on port 68. The DHCP protocol consists of 4 messages. The DHCP discover message, which is initiated by the DHCP client when it needs IP address configuration. The alpha message sent by the DHCP server in response to the discover message. The request message, which is sent by the host machine, the client, the DHCP client, when it accepts an IP address configuration from a server. And then the acknowledgement. This message is sent from the server acknowledging to the host machine that that IP address has been recorded on the server. Here's a brief explanation of each of these messages written in text form. On the edge router, in addition to configuring its name as edge, we also configure gigabit 000 as 192.168.5.2. Its mask is the .252 because it's a /30. We bring the interface up with the no-shut command. On R0, we have more things to configure. First, we configure its name R0, and we configure interface gigabit 000 with the 5.1 address on that .252 network. Again, it's a /30 because it's a point-to-point link. So let's drag that comment over to there. And that describes that link. It identifies the address on R0, the address on edge, and the interface is being used to connect them. Crossover cable because they're similar devices. Copy. Paste. Edge. Paste. And we have the green link lights indicating that both routers are up. Let's verify that we can ping from R0 to edge. Okay, and then the first failure was the ARP process occurring address resolution protocol, so both routers could learn one another's MAC addresses on these interfaces. Now on R0, we also have to configure DHCP operation. Now in DHCP configuration, you have to identify the address space. You have to identify excluded addresses, addresses that would be assigned to static IP address devices in that address space. And you have to identify the default gateway, which is the address of the router interface that serves that local area network. To identify excluded addresses, we use this statement, IP DHCP excluded address, and then you give it the starting address and the ending address in that particular range. We have 2 address spaces that we're serving, or that we're creating with this router. One on the gigabit 001 interface and one on the gigabit 002 interface. We'll have the .32 address space and that's where the gigabit 001 interface is connected, and the gigabit 001 is going to get .33, which is the first usable host in that address space. And then we have the .64 address space, and we have the .64, oops, this should be 65. And then we have 65 as the address of the interface that's connected to the .64 address space. After we configure on the router the excluded addresses, then we have to configure each address pool. The pool, a pool of addresses, gets a name. In this case, we'll do pool 32 for the .32 space. We identify the default router, which is the address of that router interface. In this case, it's gigabit 001 is going to be connected to the .32 address space, and it gets .33. This statement here identifies the address space. It's 192.168.5.32, and the mask is 255.255.255.224, which is a /27 address space. The address space for the .64 network, which is down here. We called it pool 64. We can call it whatever we want. I chose to use pool 64. Again, we configure the default router. This is the address that's going to be configured as a default gateway on all hosts in that address space. The address space itself, 192.168.5.64, 255.255.224 is the mask, again /27, exit. And then finally, on R0, we have to configure those interfaces that are in those address spaces. Gigabit 001 gets .33, and gigabit 002 gets .65. So that's where those address spaces will be connected to this router. Let's configure R0. Copy. Now we have to get into the global configuration prompt before we can paste this in. So config terminal, and now we can paste. Now PC0 represents the host machines that are in the .32 address space, and PC1 will represent the host machines that are in the .64 address space. Crossover cable because they're similar devices. Now you'll notice here that we can't get to the gigabit 002. So I'm going to do a copy run start on R0 so we can power it down and put that GBIC in place. Copy running config to the startup. Now we can power it off. Go to the physical tab, zoom in, turn it off, and we're going to put a GLC-T in this gigabit 002 slot. GLC-T. Turn it on. Now one thing we can do to verify our configurations here, enable, is show IP interface brief. And you'll see that gigabit 000 is on that .5.1, has .5.1, and it is directly connected to the edge router. The status is up and the protocol is up. Gigabit 001 is connected to the PC and the .32 network. The status is up and the protocol is up. Gigabit 002, which we just installed with the GBIC, gets .165, the status is up, but the protocol is down. The protocol is down because it's not connected yet. Now we'll connect it. Crossover cable, because routers and PCs are similar devices. Fast forward time. Now let's go back into that router. First, we get the line protocol up-down message telling us that gigabit 002 has now changed state to up. Now let's do a show IP interface brief. And it shows us that that interface, .65, the status is up and the protocol is up. Now remember, it was down in this earlier run of the show IP interface brief command because it was not the 002 interface was not connected. The status is up because we did a no shut. However, the protocol was down because it was not connected. Now, let's save this. Week 2 DHCP static routing in 2 routers. Saved. Let's go to the desktop of this PC. Initially, it's configured for static addressing, static IP addressing. When we select the DHCP radio button, or learn IP address automatically, now we get the IP address learned or assigned by the router. Now again, this interface, gigabit 001, is connected to the .32 address space, so it's providing DHCP service into that local area network. Gigabit 002 is connected into the .64 address space, and we're going to use that to provide IP addressing information to PC1. But we want to capture this in the simulator. In the simulator, show all none turns off all these protocols that could be captured. And in edit filters, we only want one, IPv4 DHCP. Now we'll go back into PC1, go to the desktop, IP configuration, select DHCP radio button. Now we'll just step through and we'll look at this packet, this frame actually. So the frame now goes to the router. Only has the inbound. Usually there's an inbound tab and an outbound tab. The destination MAC address is all F's because it's a layer 2 broadcast. The discover message is a layer 2 broadcast. And this is a DHCP discover message. The source port is port 68. The destination port is 67. All DHCP servers listen on port 67. Now this is the reply to PC1. Let's look at the inbound. Now notice here the destination MAC address is all F's. We saw earlier in Wireshark that the destination MAC address was unicast, not broadcast. It used the MAC address of the PC in the Wireshark capture. Look down here at layer 4. Layer 4, the source port is 67. It came from the server. This message came from the server. The destination is port 68. All DHCP clients listen on port 68, layer 4. Here we can also see the address of the server, and this is the address that's being offered to PC1, 192.168.5.70. Let's look at the outbound now. Now, it's a broadcast message, and it is indeed a broadcast message because there could be multiple servers on the local area network that offered an address to the requesting host. The source port number is 68. the destination port number is 67 because all servers listen on 67, layer 4. This is the IP address being requested. This is the request message. This is the acknowledgement from the server. Again, in Wireshark, we saw this as unicast, not broadcast. At layer 4, we see that the source is 67. This is from the server to the host machine. Host machine is listening on port 68 in the DHCP operation. DHCP server is listening and operating on port 67. And this is the acknowledgement of the IP address that the DHCP host has accepted. .70. Now, one other thing in this, one other component of this network that we wanted to show is the use of a static route so that this PC could ping this edge router and get a reply. Right now, if this PC pings the edge router, there will be no reply because the router has no knowledge of these two local area networks. If you look in the routing table of the edge router, the only network this edge router is aware of is the .5.0 network, the 192.168.5.0/30. It's connected to it at the gigabit 000 interface. So we need two static routes that we could put on the edge router that will give it knowledge of both of these local area networks. Configure terminal. IP route 192.168.5.32. That's a destination network, and we need its mask. .224 is the subnet mask. And how are we going to get there? We're going to get there via 192.168.5.1, which is the next hop. And we go in the same direction to get to the .64 address space from the edge router. Now if we look at that routing table, two entries installed into the routing table using static routes. The destination network is 192.168.5.32. It gets there via 192.168.5.1, which is the R0 router, and also a static route for 192.168.5.64/27. It also gets there via 192.168.5.1. So now this ping operation will be successful. More on static routes in our next class meeting. That concludes this video.